Hi everyone, welcome to My Max Academy. In this video, we'll continue with Chapter 1 Relations and Functions from 12th Standard CBSE Mathematics. In this, we will continue with exercise 1.1. Exercise 1.1 in page number 5. Page number 5 in your textbook. First problem, fifth subdivision. It has A, B, C, D, E. We'll do the A, problem A. So we have to check whether the given relations are reflexive, symmetric and transitive. So what is given? Given is A. Given is set A is equal to set of all. Set A is set of all human beings in a town. Human beings in a town. That is how set A is, and the relation R that is defined on the set is R equal to set of all x comma y such that x and y both x and y work at the same place. So what is the relation that is defined on the set A? Set A is set of all human beings in a town, and R is the relation set of all x comma y, which means two people are related if they work at the same place. Now we have to check whether this relation is reflexive, symmetric and transitive. So solution or proof, right? So what you have to check, we have to write the check. To check is if R is reflexive, symmetric and transitive. We have to check this. So proof. So proof is we will have to check whether it is reflexive, symmetric or transitive. But here, so I'll write the condition for reflexive, symmetric and transitive, or the definition of reflexive. Definition of reflexive is we should have A comma A should belong to R for every A belonging to the set A. So this is the definition for relation, which means any element that I take from A, the ordered pair A comma A should be in R, which means A should be related to itself. Now symmetric next is. Symmetric is if A comma B belongs to R, then we should prove that B comma A belongs to R. The reverse should be in R. Right? The third part is transitive. Transitive, how do we prove? Is if A comma B belongs to R and B comma C belongs to R, then A comma C should belong to R. Right? Then A comma C should belong to R. Then we call such relation as transitive relation. Now let's go to the proof for reflexive. We'll check whether it is reflexive. Now it's obvious that X is related to itself. So which means we should take an element. We'll say let X belongs to A. X is a human being. We are taking a person from the set A, and we should check whether X comma A belongs to R. If X comma X, we have to check whether X comma X belongs to R. If X comma X belongs to R, then we call that relation as reflexive. Right? Now we are taking one person, human being from A. Then clearly X and X work at the same place, right? Which means every person is related to himself, right? If a person X and the same person X both work at the same place. So which means if for X comma X to belong to R, if X comma X should belong to R, we should prove X and X work at the same place. And X and X will obviously work at the same place, the same person. is related to himself because same person works at the same place, right? So clearly x comma x work at the same place. So when x comma x work at the same place, then we can say x comma x belongs to R. And this is true for every x, which means every human being coming from the set A. Therefore, R is reflexive. Therefore, R is reflexive. The second one is we have to check whether R is symmetric. Now, second part, this is the first part. Second part is for symmetric. So what do we do? We'll say let for symmetry to check symmetric or to prove symmetric, we should take one element from R and we should show that the reverse is in R to prove it is symmetric, or we should say reverse is not in R to show that it is not symmetric. So we'll take we'll say x comma y, right? Or we can, I mean, if x is okay, let x comma y belongs to R. Now we should prove y comma x belongs to R because there is a definition, right? If a comma b belongs to R, then the reverse should be in R. Now let x comma y belongs to R. We should prove y comma x, the reverse should be in R, right? So we let x comma y belongs to R means what is the meaning of this? When x comma y belongs to R means x and y work at the same place. This implies x and y work at the same place, which means y and x work at the same place. Y and x work at the same place. The reverse also work at the same place. So which means, this implies y comma x belongs to R. The moment you get y and x work at the same place, if y and x work at the same place, then y comma x will belong to R. So whenever x comma y belongs to R, y comma x belongs to R. This is true for any x comma y we take from R. Therefore R is symmetric, which means symmetric relation. Fine. Now we should check for the third condition, which is transitivity. For transitivity, we will take two elements. Let x comma y belongs to R, and y comma z belongs to R. If x comma y belongs to R and y comma z belongs to R, we should prove x comma z belongs to R. That is for the transitivity. If a comma b belongs to R and b comma c belongs to R, then a comma c should belong to R. And that should be true for every pair that we take from R. Should be true for every pair that we take from R. Now what is the meaning of x comma y belonging to R? This means x and y. This means x and y work at same place, and y comma z belongs to R means y and z work at same place. Now if you observe that x and y work at the same place and y and z also work at the same place, means x and z they work at the same place, right? So this implies x and z work at same place. Now when x and z work at the same place means x comma z belongs to R. So this implies x comma z or z belongs to R. Fine. So therefore we can say we can say R is transitive relation. So here your R is reflexive, symmetric as well as transitive. Fine. So all of you can pause the video and take the notes. I'll go to the next problem, which is problem number B of the same first problem, fifth solution B. Right? So here is this. Now what is given? What is given is A is, again A is set of all human beings. Okay. So A is set of all human beings in a town, and the relation R is defined as set of all x comma y x comma y such that x and y live in the same locality. Now we have to check whether R is reflexive. Check if R is reflexive, symmetric and transitive. Fine. Now again, so if you see this, I will just explain this problem, which is similar to the earlier problem that we did. So again, both two people are related if they live in the same locality. So how would the proof goes, or how do we prove that they are reflexive, symmetric and transitive? Yes. Now let x belongs to A. We'll take a person from A set. Then clearly x and x they live in the same locality, right? Which means every person is related to himself because x and x live in the same locality, right? We should write that x and x live in the same locality. So x comma x belongs to R. So R. No, when x no. So that R is reflexive. No. Then let x comma y belongs to R. This is for symmetric. Then x and y work in the same locality, right? So I will just change this. So x belongs to A. Clearly x and x live in the same locality. So therefore x comma x belongs to R, therefore R is reflexive. Now to prove symmetric, we should take like x comma y belongs to R, which means x and y live in the same locality. Live in the same locality. So here also, which means when x and y live in the same locality, y and x also live in the same locality. So therefore y comma x belongs to R, therefore R is symmetric. Now let x comma y belongs to R and y comma z belongs to R. This is for transitivity. Then which means we can say x and y live in the same locality and y and z also live in the same locality. Therefore this implies x and z also will live in the same locality. Therefore this implies x comma z will belong to R. That makes R as transitive. So this is how we prove that the relations are, the given relation is reflexive, symmetric and transitive. The same like the previous one. So I just modified the earlier A subdivision for B because both are almost the same. The early A was both work at the same place. Here both live in the same locality. Fine. So therefore R is transitive also. Fine. So you can pause the video and take the notes. I'll go to the next problem, which is problem C. In problem number C, in first problem, fifth subdivision C. Same A is set of all human beings, but R is set of all x comma y such that x is, the definition of R is x is exactly 7 centimeter taller than y. X is exactly 7 centimeter taller than y. Two people are related if one person is exactly 7 centimeter taller than the other person. X is exactly 7 centimeter taller than y means x and y are related. Now we have to check whether if R is reflexive, symmetric and transitive. Now we will take an element x belongs to A. Then clearly what we see is we need to check whether x comma x belongs to R. X comma x will belong to R or x comma x belongs to R when x comma x will belong to R if x is exactly 7 centimeter taller than x. How can x be 7 centimeter taller than himself? That's not possible, right? So we'll say clearly x comma x does not belong to R because x is not exactly 7 centimeter taller than x. X is not 7 centimeter. X is not exactly 7 centimeter taller than x. How can the same person be 7 centimeter taller than himself or herself? It's not possible. So clearly x comma x does not belong to R because x is not exactly. Therefore we can say, so therefore we can say R is not symmetric. Therefore R is, sorry, not reflexive. We can say R is not reflexive. Then we need to check for symmetric. Now we'll take the second one. Second part is, we'll say let x comma y belong to R. Now we need to check whether y comma x belongs to R. If y comma x belongs to R, then R becomes symmetric, right? So to prove R is symmetric, we should take a pair first, a comma b from R, and we should prove b comma a belongs to R. Then R becomes symmetric. Now let x comma y belongs to R. Now we should check whether y comma x belongs to R. Y comma x will belong to R if y is exactly 7 centimeter taller than x. Y comma x will belong to R if y is exactly 7 centimeter taller than x. Then y comma x will belongs to R. Now we have x comma y belongs to R. What is the meaning of this? This means x is exactly 7 centimeter taller than y. Right? X is exactly 7 centimeter taller than y. This means what? Y is not exactly 7 centimeter taller than x. Right? If x is exactly 7 centimeter taller than y, then we cannot say y is also exactly 7 centimeter taller than x, right? Therefore y is, so which means simply y is not exactly 7 centimeter taller than y. Therefore y comma x does not belong to R. Therefore R is not symmetric. Therefore R is not symmetric. Fine. Now the third one, for transitivity. For transitivity, we'll take two elements and we'll see whether the third element belongs to R. See here the thing is, R is defined in such a way. So which means we can't list on all the elements of R because there are many people or many human beings in that top. So we can't list all the people here, and we don't know who they are also, because A itself is not given in terms of A is not given in the roster form, and also A is a kind of a big set. More people will be there, so we can't write all the elements of R here. We don't know the elements are R because they are human beings, right? So we'll have to generally try to prove or disprove whether it is transitive, symmetric, or reflexive. Now transitivity part is, to check for transitivity, we'll take two elements from R. So we'll say let x comma y belongs to R and y comma z belongs to R. Now we should check whether x comma z belongs to R. If x comma z or z belongs to R, then we will say R is transitive. If not, it is not transitive. Now x comma y belongs to R means what? What is the meaning of this? This implies x is exactly 7 centimeter taller than y. And this is and y comma z belongs to R means y is exactly 7 centimeter taller than z. When x is exactly 7 cm taller than y and y is exactly 7 cm taller than z means what? X is exactly 14 cm taller than z, right? See, it comes like this. So y is or x is 7 cm taller than y means x is 7 plus y. And y is 7 cm taller than z means 7 plus z. Now then x becomes what? X becomes 7 plus, instead of this y, I will substitute y 7 plus z. 7 plus z. Right? So if I put that, I become x is equal to 14 plus z. Which means x is exactly 14 centimeter taller than z. Which means x comma z will not be in R. For x comma z to be in R, we need x is exactly 7 centimeter taller than z. X is exactly 7 centimeter taller than z, then we can say x comma z belongs to R. Right? So therefore we'll say, so this implies x is exactly 14 centimeter taller than z. Therefore x comma z does not belong to R. Therefore R is not transitive. Therefore R is not transitive. So it is neither reflexive nor symmetric nor transitive. None of the three. Fine. So pause the video and copy these notes. I will erase. So A is the same set. So we are going to do the D part. D part. Given as A, set of all human beings in the town, and relation R is given as X is a wife of Y. X is wife of Y. We have to check whether R is reflexive, symmetric and transitive. So we will again take X belongs to A. Clearly X comma X will not belong to R because X is not wife of X. Right? X cannot be wife of himself or herself, right? So X is, so two human beings are related if X is a wife of Y. But here for reflexive, what we need to have A comma A belongs to R. For any A we take from A. So if I take an X from A, if X comma X belongs to R, then we call R as reflexive. But for X comma X to belong to R, X is a wife of X. But how can X is a wife of X? X cannot be wife to himself or herself, right? So X is a wife of X is not possible. Therefore R is not reflexive. Then for symmetric, we will take let X comma Y belongs to R. Then this implies what? This implies X is wife of Y. X is wife of Y because X comma Y belongs to R. Now we should check whether Y comma X belongs to R. For symmetric, if Y comma X, if A comma B belongs to R, then B comma A should belong to, the reverse should be in R. Then we call that as symmetric. Now X is a wife of Y. This implies obviously Y is not wife of X. If X is a wife of Y, Y is not wife of X. Y will become husband of X, right? Right? Y is not wife of X. Therefore, Y comma Z does not belong to R. Therefore, R is not symmetric. Fine. So now we'll have to check transitivity. For that, we'll take X comma Y belongs to R and Y comma Z belongs to R. Now, if X comma Y belongs to R, which means X is wife of Y and Y comma Z belongs to R means what? Y is wife of Z, which is not possible because X is wife of Y, right? X is wife of Y and wife is and Y is wife of Z is not possible. X is wife of Y and Y is wife of Z is not possible because if X is a wife of Y, Y becomes a male. How can a male is a wife of someone else? Right? So which means we cannot even take such pair. This pair does not exist. So X comma Y belong to R and Y comma Z belongs to R. We cannot even such a condition, right? So which means is not possible. So which is the above case is not possible, which means we cannot even take such pair. We don't even have such pair. You cannot find any element, two elements like a comma b belongs to r, b comma c belongs to r. This itself does not exist. We cannot find such pair. So it becomes transitive. If we cannot even find such two elements, then we cannot say a comma c belong to c or does not belong to r. Sorry. We cannot say a comma c belongs to r or a comma c does not belong to r. For that to be there, we have to first of all get a pair like this. If you are not able to get a pair like this, then we will say it is transitive. Because only if such a pair exists and if a comma c does not belong to r, we can say it is not transitive. If I am unable to find such two pairs, then we cannot say it is not transitive. It is transitive. So the above case is not possible. So R is, this is very important. People may get confused. So R is transitive relation. If you cannot even find such pair, then immediately you can say it is transitive. If you are able to find such pair, and then if x comma z does not belong to R, only in that case it becomes not transitive. Clear? So therefore it is transitive. So it is not reflexive, not symmetric, but it is transitive. This relation is a transitive relation because the given condition for transitivity itself will fail. I need this condition to check whether a comma c belongs to R. If I am not even able to find such a pair, then immediately we can say it is transitive. Fine. So this may be a little confusing, but this is how the logic is. If the if condition fails, if this condition itself fails, means the entire condition is true. The entire condition is true. Which you might have studied in mathematical reasoning in your 11th standard. Fine. So now you can pause the video and take these notes, and I will go to the next one, which is E part. E part. In first problem, E subdivision. A is set of all human beings as it is, and what is X is a father of Y. X is a father of X is a father of Y. Right? Two people are related, X and Y. If X is a father of Y, we have to check whether it is reflexive, symmetric, and transitive. Now let X belongs to A. Same kind of explanation we are going to give to this problem as well. Let X belongs to A, then clearly X comma X does not belong to R because X is not father of X. X is not father to him. X is not father of X. Therefore, R is not reflexive. How can a same person cannot be father to himself, right? X is not father of X. Therefore, X comma X does not belong to R. Therefore, R is not reflexive. Now, let X comma Y belongs to R, which means X is a father of. This means X is father of Y. This implies Y is not father of X. Because X is father of Y means I cannot say Y is a father of X. Right? Y becomes son of X. If X is father of Y, then Y is son of X. Right? This implies Y is not father of X. So which means Y comma X does not belong to R. Right? So if X comma Y belongs to R, we cannot say Y comma X belongs to R. We cannot say that. Which means if X comma Y belongs to R means X is a father of Y. If you have to prove Y comma X belongs to R, we should prove Y is a father of X. So if X is a father of Y, then obviously Y is not father of X. Therefore, Y comma X does not belong to R. Therefore, R is not symmetric. Now, the third condition is to check transitivity. Let's X comma Y belongs to R and Y comma Z belongs to R. Then when X comma Y belongs to R, which means X is father of Y. Right? X is father of Y, and Y comma Z belongs to R means Y is father of Z. So this is possible. X is the father of Y means Y can be father of someone else. That is true. So which means if X is the father of Y, X is the father of Y and Y is the father of Z, then X will become X is grandfather of X becomes grandfather of Z, right? X is the father of Y, right? X is the father of Y and Y is the father of Z, which means X becomes X is grandfather of Z, right? So that which means X is not father of Z. X becomes grandfather of Z. For if X comma Y belongs to R and Y comma Z belongs to R, for transitivity we need X comma Z belongs to R. X comma Z will belong to R if X is the father of Z or Z. X is the father of Z, but X is the grandfather of Z. Therefore, X comma Z does not belong to R. Therefore, R is not transitive. Not transitive, which means R is not a transitive relation. Clear? So, so this is how we prove or we check reflexive, symmetric and transitive. All of you pause the video, take the notes, and I will stop the video here. Please watch my next video for the continuation of this exercise. Thank you for watching. See you in the next video. Thank you.